Data is a precious thing and will last longer than the systems themselves, said by Tim Berners-Lee. Good morning, good afternoon, and good evening to everyone joining us from across the globe. A massive warm welcome to all of our data enthusiasts, professionals, and lifelong learners. You're turning into another exciting edition of the Data Analytic Group 1 Hour Bite. We are absolutely thrilled to have you here online with us today. Today we are diving sorry. Today we are diving deep into a powerhouse topic that is shaping the future of data workflows. Get ready because over the next hour we are exploring fabric data engineering with Python notebooks. Whether you are looking to optimize your pipelines, harness the power of Microsoft Fabric, or level up your Python notebook skills, you are in exactly the right place. To guide us through this technical journey, we have a phenomenal expert with us today. Our guest speaker is a true veteran of the industry with over 30 years of data processing and proven project management experience. He specializes across banking, healthcare, and government sectors and has been recognized as the Microsoft Most Valuable Professional for multiple years for his outstanding contributions to the data platform. He currently works as a senior data architect at Insight, helping corporations solve their toughest business needs with cutting edge data solutions. On top of that, he is the long standing chapter president of Rhode Island SQL Server User Group. Everyone, please give a massive, energetic virtual welcome to the incredibly knowledgeable John Miner. John, we are very excited to learn from you today and see these notebooks in action inside Microsoft Fabric. The floor is
Awesome.
officially yours and let's get started.
Thank you for having me. I appreciate everyone attending wherever you are. I'm going to go off camera. I'll go back on camera at the very end and we can answer questions, okay? So I'm going to share my screen, okay? And we'll start. So I want to point out a few things. First, and these are already in the actual chat window. Okay, there is a link to my GitHub repo. I've done a lot of stuff for the community over the last 2 decades. Okay, and if you look, there's a directory called Python notebooks. Okay, and anything that we're going over today, which is the code, okay, as well as the presentation and some notes are actually there for your use. Okay, so free of charge. Next thing I like to do is I'm an avid learner for most of my life, and I'm also a undergraduate and graduate degree in computer science. So I love learning stuff. So what we're going to talk about DocDB today. We're going to talk about Pola's database. We're going to talk about Python notebooks. What's the difference between them and Spark notebooks? And if you go a little farther down in the talks, you can see something that goes over let me see if I can find it. It's somewhere here. It's probably page 1. And we're going to talk about shortcuts too. So let's get into the presentation, okay? So today's world, we want to go ahead and do the best we can for our customers, okay? And that includes data processing, but doing it effectively and cost efficiently, okay? And so again, my name's John Miner. I'm a data architect at Insight, and we're going to talk about fabric data engineering with Python notebooks, okay? So the question is, what's the right tool for the job, right? Not all workloads require Spark, okay? Spark is for big data, okay? It's distributed computing. Most organizations operate on small to medium data, okay? So you can pick the right tool, right? And the right tool would be Python to optimize for cost, simplicity, and performance, okay? Um, we can see, again, the topics I'm going to talk about is Python, okay, because that's the core language. We're going to talk about Jupyter Notebooks, which is part of Fabric. We're going to talk about Polas. This is a new data frame compared to Pandas, okay, and then DuckDB. Okay, so when to use a Python notebook? Again, small to medium data set. It's for lightweight ETL, so if we're talking terabytes of data, probably not going to want to use a Python notebook. But if you're talking about gigabytes of data, this is a perfect way to ingest data, okay? We can also do API integration. Say we have to call a REST API endpoint. Say I have some address data and I want to enrich it with graph data from, and I'm talking about like map data from Microsoft. We can do that. Okay, so there's something new called Azure Maps. It used to have Bing Maps, and we can do that. We can also do interactive data or exploration. Okay, so these notebooks can be used to query those, Delta tables. Capabilities. We can combine Python and SQL. There's some new shortcuts that they just posted, so I'll go over those. And what I mean by shortcuts, those are the magic commands, okay? We got built-in visualizations and scheduling, and we can collaborate within the workspace, okay? Advantages. Why do you want to use a Python notebook? You want to use a Python notebook because first, they're part of the starter pool, and they come up in seconds. But the main thing is the low cost, right? We'll talk about how many cores Spark uses in a minute, but this one uses two virtual cores, okay? That means that um, you're using a lot less consumption. Now, just remember back in the day when I first started off computing, one of the things that was really popular was systems like Unix, right? Or, um, mainframe or VAX, right? And those were centralized systems, right? And you all got time sharing, right? And guess what? Fabric is just like that, okay? You got a capacity, and you only got so much capacity. And we'll talk about how to do more with less, okay? Um, Again, the Python has a full ecosystem, pandas and polas, and we'll talk about pandas, polas, delta, and DuckDB. Okay. So what is the design pattern for Python notebooks? And we're going to compare in the first example, I think it was Spark bit versus Python, right? So we want to read the data into the data frame, transform it locally, and write the data to a data lake using API, right? So Pythons act as a single node data engineering engine, right? That's all it is, okay? So we're going to escape and we're going to do our first two examples. And this presentation is going to be really heavy on examples, okay? So we can see that I have a workspace and it's called Python versus Spark Notebooks. And if we go into the clear, okay, we can see that we have a bunch of silver and bronze tables here, right? We also have some files here, okay? One of the things I want to talk about is shortcuts, right? Shortcuts are a great way to get data into the Fabric ecosystem without actually doing any engineering, right? So this is the credentials for my Azure Data Lake storage. And you can see Sales LT is one of the Microsoft databases from SQL Server a long time ago. And what we do is we have it broken down, okay, by CSV files. And these are pipe delimited CSV files, okay? I just happen to know it off the top of my head. But we can see I didn't do any work. I didn't have to connect to ADLS and say, hey, what's there? It automatically connected to my ADLS storage account. You can do that with GCP and you can do that with AWS, as well as there's some new shortcuts I talked about, like um, SharePoint and OneDrive, okay? So very powerful. So please look into using shortcuts, okay? So the first thing is we're going to basically say, hey, guess what? Look at the tables in blondes. Now, the interesting thing is that what's different here, right? Well, this one has been deployed, okay, with schemas, okay? And schemas are relatively new. In the past, what we used to have is we used to have just DBO, right? And then everything would be, it wouldn't even be DBO, it would just be root tables and you had a bunch of tables here. And if you want to separate bronze from silver, you would have to put BR, say, for bronze, AG for silver, whatever you want to use for acronyms, and it would tell the two names, right? So we want to do some cleanups. And what we're going to do is we're going to say, hey, and there's two ways to do it. We can use the new syntax in which we say show tables, and before it, we wouldn't have to specify a schema. Now we have to specify a schema, and it'll collect it and tell us what the tables are. Another way is we can also say, get me a list of all the tables in the storage, right? Because this is really just storage, right? So if we look at tables, bronze. We got DuckDB, and underneath the DuckDB, there's just a bunch of Delta files here, right? We can see that it won't show you in this view the Delta files. So what I'm going to do is I'm just going to run and drop all these tables, okay? And you might say, oh my God, he's dropping all the tables. Not a big deal because we're going to rebuild them. So we're going to talk about some stock data today, some weather data, okay? And that'll be the different ways to do it with pandas, DuckDBs, polars, and so on. So I just ran the script, and again, this is not something that you'd probably do in a production environment because I just went ahead and got rid of all my tables, but I have all my tables going, okay? So let's close out of here and stop and close. Now, one thing I want you to do is make sure that you stop and close it, right? Second thing is that before I get out of here, well, I hit the button, but go back really quickly in. One thing you can see, this is a PySpark, okay, notebook. It's not a Python notebook, okay? So we're going to stop the session, right? If you don't stop the session, what's going to happen is it's going to chew up, okay, your capacity, right? We talked about this limited capacity. So see, this failed because I probably didn't have it scheduled or something. Again, I do a lot of demos. They might not all work every single time I look at stuff, but we're going to go into the second notebook. So now we have our tables and there's nothing there in his files, okay? So the first thing is, this is again a PySpark notebook, load delta table using Spark, right? So if we use MS Spark utils, it's a utility. FS means file system. There's a bunch of functions there, like remove directory, copy file. This is list the files in the directory weather, okay? So I'm gonna run this. And there's two files. There's a high temperature file and there's a low temperature file. And again, there's many different ecosystems out there. I call them ecosystems, but like Fabric, right? There's also Databricks, and Databricks has its own things too. But this is core. Other than the Spark utilities here, they have DB utils for Databricks, so it's cross, platform, not specific. And Python notebooks are very specific to Fabric. Okay, so we're gonna read the format CSV, say it's a header, right? And we're going to read it in. And one of the cool techniques for data engineering is to create and replace a temporary view. So I'm going to create two views. So I have two data frames, but I don't want to join the data frames using a join notation. I want to be lazy and use my SQL knowledge that I've built over the years, okay? So one of the things you can do is percent SQL, and what this allows you to do is it allows you to do ad hoc SQL. Now, right now, we can see I created those two tables, right? But they're not showing up. They're actually temporary tables, okay? But they do exist. So now if I run this, right, it's actually going to join the two, and it's going to give me a low temperature and high temperature, okay? So the final thing is we can say create schema if none exists. It's not going to work because it already exists, right? And we can also, a good practice is that if we're going to build the table from scratch, we want to say drop the table if it exists before rebuilding it. Okay, so we're going to do that. And then the reason why I did this is this allows me to take the two data sources that I read in the data frames, convert them to temporary views so I can use that SQL knowledge, temporarily figure out the exact query I want to use, okay? And then what I can do is finally add some code, right? And I would comment that section out in the notebook. So we can say select the observation date because it's a date for each table. I only want one. I'm going to rename temperature as low temperature from the low data set or file. And I'm going to rename the temperature as high temperature from the high file. And I'm going to join on date. And last but not least, I'm going to write it out, save as table. Okay, so I'm going to run this one. Now we can see right here, it's running it, and there's no information on how much this is costing. But no, I'm going to tell you ahead of time before we get to it. It's actually costing 8 CUs, okay, which is capacity units. So if I have an F16, I only have 16 CUs. So I'm using half of them to run this job, okay? So it's done now. If we hit the refresh button, and that's like Microsoft, we can see the spark.weather, okay? Let's close this example and go to the second example, and then we'll always again stop and close, Otherwise, if you go to monitoring, right? I don't know why it's showing failed. There we go. That's why. Hit refresh, clear all. There we go. We can see that. Here's my first two notebooks. There's stop, and we can see these in stop stats. That's really good because we don't want to leave anything open, okay? Second one we're going to talk about is how to do the same thing with pandas. Now, pandas, okay, is going to be a Python notebook. How do we know it's a Python notebook? We can see right here it's a Python notebook. It says Python. There's many different types. I'm not going to talk. We talked about Python's PySpark, right? But you can also do it in Scala. You can do strictly SQL. You can do in R. We also have Python, and if you're using a warehouse, you can do T-SQL, okay? So what we're going to do is we're going to connect to this. Okay, now there's going to be some things that a little different, okay? For instance, some places want the actual mount point, and there's a default mount point, okay? So I wrote this little function, capture, and capture means don't show it. So let me do a pound in front of this, okay? And just run this and show you what it looks like. So now it's restarting the kernel. At the bottom, we see now we're using one CU, which is two virtual cores, okay? And we can see it's only 16 gigs of RAM. Now, this is something we can change in the future. We'll talk about that. And we can see that the default, okay, is actually pointing to this blob storage, right? This is the blob storage that's automatically attached, okay, to your Fabric instance. One lake, and then this one right here is your actual workspace, and this is your lake house. And again, I just know those from using them for a while. And we can see it's lake house default, okay? The capture thing, which is kind of cool now, it's a new feature, is I can run this and it actually runs this code, right? And says, hey, figure out the mount points from notebook utils. Oh yeah, guess what? Notebook utils, that's something new, right? Before we had MS Spark utils. And when they first put out Python, they didn't have this. Now we can figure out all the things you could do in the Spark using the notebooks utils. Okay, so there's the MS Spark utils and now it's notebook. And this is just is basically getting a new path, right? So now I'm going to say import pandas, read it as a CSV and display the top five, okay? Can do the same thing. The only difference now is, guess what? There's not going to be anything to help us do this fancy convert it to SQL and abstract the data frames and join it. But we can merge it, right? So PD, merge, first data frame, second data frame on date, and show it. So now we can see that we have temp X and temp Y. It automatically created those for me. That's not how I want to save it though, right? I want it to look exactly the same as before, right? So all I need to do is I need to use some commands in Python, pandas to rename it. So I'm going to rename the date to observation date, temp X to observation low temp, observation high temp is temp Y. Now I got my target the way I want it. And what I do is remove the target. How do we do that? Well, we got a schema, we got a table. It's that path I got slash table, okay, slash schema slash table name, okay? So we can see this is going to bring the lakehouse path that we pulled before, and we're going to say if it exists with the schema and name under tables, then remove it, okay? So what we're going to do is we're going to, why did it do that? I don't know. Connect. Let me go see something. So I have, and this is kind of good and bad. Let's look. I bet you I know exactly what happened. I have a job that turns off my Fabric just in case I fall asleep and I'm working on something, it'll just keep on running. And guess what? See, it killed my capacity, okay? And without any capacity, we can't do any work. So let's restart this and then we can go right back to it. Okay, so that's why it killed the job. So we're going to have to restart this again. We're going to have to run this guy. Let's say reconnect. Come on, session stop, connect. Of course, there's always an issue when doing live demos, especially a lot of them. Okay, let me close out of here and come back. And again, we're doing the second example, right? Okay, if we look on the tables, right? On the bronze, we only have the Spark. We're going to do the pandas, right? We need a connect. Not connected. Why is it saying not connected? Okay, gotta do one more thing. Sometimes when you do a capacity, it just gets in a really weird state. We're gonna go and say it's active, so it's definitely active. And what I'm doing is I'm re-signing into my account. I got out. It's the usual Windows thing. If something doesn't work, get out and come back in. And then Python versus Spark, and we're on the second notebook, right? Pandas weathers. Let's take a look. Hopefully it works this time. Okay, I'm gonna connect. Like this. Don't tell me there's something going on today. Okay, let's go to monitor. I apologize, something went really weird to my system today. Okay, it just took forever. Even though I did do it, it went back and took forever to figure it out. So it's running now finally, even though I said connect and it ran through, read this one, that read this one, it joined the two, right? It renamed everything, right? Removed the target, right? And then it said created a delta table. Okay, so it created it under bronze panda wealth, and then oh, look at this. And what this does, this is a new feature. Okay, so let's take a look. This is something new. Now this is interesting because behind the scenes we do not see it showing up here, right? Even though it's there, we know it's there, right? It created it, right? Create table, it executed. If we run this, this is a new syntax and there's a programming error because this is the endpoint. The endpoint hasn't been updated, okay? Now this is the Explorer, and this is one of the problems you might encounter. Is this date right? This is 425. So this, even though it said it ran everything, I'm looking at an old run, so let's run it again manually. And again, I apologize, the demo gods weren't nice to me. Shut my computer off in the middle of the demo, but it should work now. So now we got the two, right? We're gonna join it, okay? And then we're gonna prepare for writing. So we're gonna rename the column headers, gonna remove the target if it exists. Okay, and we're gonna run it. Okay, cool. So now if we come here and hit refresh, okay, we're gonna have another one. The question is, we run this, this is gonna error out. Why is it erroring out? Okay, this is a very important concept, okay? There are two endpoints. There's the Lakehouse and there's something called the SQL Analytic endpoint. Okay, the SQL Analytic endpoint is something that Microsoft came up, and it has to be transferred. Okay, data has to be transferred from okay the Python or the your Spark ecosystem to this system that allows it to look like SQL. It hasn't actually happened, right? So if we say select star from this. In fact, you know what's funny is it's probably showing me a bunch of junk because I know all these have been deleted, right? But they're still showing up, see? Which is crazy. They shouldn't be there, right? But we know the data is here, right? Because if we go to Pandas, right click and hit load data, it's going to create me a quick statement saying, hey, here's the path to it. Use DuckDB and scan the first 1,000 records, and guess what? It's going to bring up data. So again, when using this, remember that the analytic endpoint does not refresh as fast as the Python notebooks, okay? So with that, I'm going to stop the session. And you can force it a refresh using the API, such as semantic link, but I'm not going to go into that today. And we're going to go back to the slide deck. I spent a little too much time in there. I'm going to try to do a couple more slides and then go into just demos. So why use Python versus PySpark, right? PySpark is really good for distributed processing, large scale workloads, complex ETL. Python notebooks are good for low end cost. So if you got a small client then try to use Python notebooks. It'll save money. You can do more with less, right? Remember we said that F16 to run two jobs, the same jobs to load data, okay, at the same time, is going to cost you 8 CUs and 8 CUs, so you can only run two in the F16, right? If I wrote everything in Python notebooks, I can run 16 jobs because they only run with one CU, okay? So again, you can look at this matrix over here, but I am going to fast forward. The guidance is use Python first and then use Spark when scale demands it. Is there any questions? Someone's on off mute. Okay. So again, I'm going to reiterate this benchmarks, right? Python 1 CU, slower for massive parallel ingestion. We're going to go over that next. If we're doing lots of files, then it's not going to win. Spark, faster for large scale, much higher capacity consumption. Okay, so you're going to use 6 capacity units. Okay, and again, because you're using less, you can have more concurrent jobs, and it's, effective for small companies. Basically, you can do more if with less if your data fits in memory. So it has to fit in the memory. So far we saw 16 gigs. So let's do examples 3 and 4. So again, this has been stopped by itself, which is awesome. Always check it. We can go to monitor. If there's anything that says it's running, kill it because again, you only have so many CUs. Go back to the workspace and we're going to go to ingest a CSV file with PySpark versus Pandas, okay? So this time we're going to talk about some stock data. And I have this one because we talked about weather so far, right? And if we look at the weather, there was two high temperature and low temperatures. Stock data. We have 5 years of S&P stock data and it's just CSV files, okay? So what we're going to do is we're going to go ahead and again connect. And this is, okay, new standard session. So this is the PySpark version. So to make sure I was right. So now it took a little while, but we get those 8 CUs up, 8 cores. This one's going to say, hey, bronze.spark data. If it's there, drop it. Okay. One of the things we want to do is when we read CSV files, we want to use a custom schema. It actually makes it go faster, okay? Especially any text files like JSON, XML, etc. Always use some type of schema. So the path is file.stock. So this is totally different. We don't have to have the ADLS like we did before. We read it in. We can say recursively read it. So that's something different too. We'll talk about that. And we're going to say, hey, look for any CSV headers because some garbage junk, and we're going to rename everything, okay? Then we're going to write it out, okay? So let's run this. So we're going to go back to tables, go to bronze, and when this is done, we should have something called spark.weather. So let's look at the timing. So it's still running. It actually created this already, right? And I don't know why there's an X there, but there is. And it's still running, so even though it's there, I don't think it's available because it says could not load column details yet. So it sees there's something in that directory, but doesn't understand it yet, okay? And now if we go over here and hit refresh one more time, it actually sees the data, okay? So again, that happens a lot quicker. We can go ahead and count. So this took 38 seconds, so it's reproducible, which is awesome. Same CUs. Okay, so we're gonna say select count from stock data, how much there's this 626,714 rows, okay? Again, we can group it. So nice thing about, both of these, you can do percent SQL. This is going to query it right against the engine. We're going to look for Amazon. Okay. So again, remember this recursively read all the files up. Let's write out a single file and see how long it takes to load. Okay, so 38 seconds for multiple files. And this one is going to, oh, that took a little while. So 25 seconds to figure out one, right? So we're gonna drop the existing file if it exists. Same thing, but this time we're going to go ahead and read everything and write it out as one file. So we're picking one file out of it, right? 5 years of it. So there you go. So this is going to create in the stocks directory under files root directory, maybe. There we go. Right, one file. Okay. And we can take a look at it, and it should have, go here, hit refresh. This one file should have the same number of rows. It does. And we can look at Microsoft stock. Okay, that's fine. And if we want to see if there's any dividends, should filter them out. There's no dividends. Okay, awesome. So we can see that, writing out a single record didn't take that long, right? It took 7 seconds. Let's see how this fares when we use Python, okay, pandas. So now I just stopped that. And what we're going to do now is go back and run the third demo. And this one is, or fourth, it's pandas and just CSV files, okay? So remember, last time we ran it, it took 38 seconds. Something to keep in mind. Again, I'm going to check the monitor. Everything stopped. That's good. So I'm not chewing up my capacity. Again, percent capture says, hey, run it, but don't show me output. So I get the lakehouse path as a ABFS format. Okay, so I'm going to write a little function. This is going to say, hey, give it a root directory in a pattern, return a data frame. So it's going to get the path. Now the problem is with pandas, there's no way to say recursively read up my 2500 files plus. But we can use something called rglob, which is a pandas path lib. And what we can do is it will go through and get a pattern. It gets all the files. And then we're just going to panda all the data frames. And then we're going to concat the data frames. And then we're going to return a single data frame. Okay. So that's how we would do it there. And then basically recursively, we're going to give it the full path to the stocks and the pattern. And what it's going to do is it's going to read everything up. And again, we're just duplicating what we did in Spark using pandas. Is there a question? Okay. Cool. So last time it took 38 seconds. This one, okay, again, we talked about the trade-offs, right? Spark is fast because it has a 3-node cluster, so it can divide and conquer. Okay, so it took 38 seconds to read in 2,500 files. This one now is single-threaded, right? So we got two vcores. Now, again, I could try to go back and try to parallelize this into two vcores and say, well, I have two threads, go ahead and try to run one thread and take half the list to read it in the other thread, use the other half. Maybe I could reduce it a little. But regardless, if we just blindly wrote some code and said, hey, recursively read all the files, it takes about 2 minutes. Let's look at the rest of the code while we're waiting. So the rename, so we say for columns, for each column in the data frame, right? So pandas data frame.columns, create st, and then rename it. And then what we do is we say any volumes that are not equal to 0, save them, otherwise do it. We can get the shape, and now we can see we have the similar shape. How do we get rid of stuff? Same thing. Get the full path and say notebooks utils, remove it. Write the delta tables, right? So now what we're going to do is we're going to import a library called delta, okay? And from that library, we're going to write to the delta table. So we're going to say create delta table at, write delta table, give it a pandas directory, the data frame, and just a fabric folder directory for the path to the table, data frame, overwrite. And then we can also write a single file. So we'll see what the difference is, okay? So this finally finished, and guess what? It took actually 8 seconds longer. Okay, let's rename it. So this renamed it, shows the shape. We got the same data set. Awesome. Gonna remove it. So if we go down here, maximize tables, bronze, right? Gonna remove it. We're gonna now create a new delta table called path. So it's going to be pandas. So now if we right click and hit pandas, we should have a pandas stock data. Okay, awesome. What we can do now is we can write a single file. So path equals here. We're going to read that single file in, right? We're going to give it encoding, tab to separate it, index and header. Boom. And it's wrote it out. And now we're going to read it back in. So how long does it take if we have a single file? Remember last time it took us 7 seconds. This took 1 second. So again, when using pandas, some things will be faceted, right? And then what we can do is write that single file out. So we're going to remove it. And we're going to write the second data frame out. Okay. Again, is it there? So if we hit refresh, this is the Spark catalog. We can see it's there. We go here. And guess what? It doesn't understand it. Why not? So let's go back to workspaces and take a look, and then we'll go on to the next sample. So we can see this is SQL Analytic endpoint. And what we're going to do is we're going to go to bronze under the tables and hit refresh. So it looks like it finally showed up here. And if we go back here, does this work now? Yes, it does. So again, there's some time delay between the syncing of the Spark system and the artificial SQL analytic endpoint that allows you to T-SQL against the Spark, okay? And this SQL analytic endpoint can be accessed, okay, with SQL Server Management Studio or any favorite tool that supports tabular data stream, okay? So we talked about cost performance, how to do it with pandas. So again, there's some more libraries that we can look at to go faster, right? So far we talked about how pandas can save you money, but how can we go a little faster? Pandas was developed a long time ago, about 20 in the 90s, right? Polars was developed a few years ago, okay? It's a faster data frame engine. There's also DuckDB, and DuckDB allows you to do transformation using SQL, and it's an in-memory database, or it can be on file too. And the key benefits is basically faster local processing, as long as it fits in memory or disk, and less overhead, okay? So let's talk about the new notebook configuration utilities. And again, I'll go over it really quickly. You can configure with the magic command. You can pass parameters for the environment. You can install libraries. Whoops. Utilities. You can interact with OneLake, Lakehouse, SQL Warehouse, and SQL Database. Okay. So let's bring up the next demo. I'm going to stop and close. And again, always stop and close is really good. And I always, you can see as a developer, I always want to make sure that I don't have any capacity running, otherwise I'll run out. Okay, so Python notebooks, utils. Okay, one of the things I showed you so far is when we start, like if we connect, okay, and that doesn't run anything, we're just connecting, we get 2 vCores and 16 gigs of RAM. What if I want to change that? Well, we can change that by using something called the config. Percent config is a magic command. Give it a pass an F, and then you give it a JSON blob. And in the JSON blob, we can do, for instance, call how many cores there are. We can define the lake house. And the default lake house, which attached during this, we'd have to give it the name, the ID to the lake house, and a workspace ID. We can also give it mount points. As long as the person who's running this has access, I can say, hey, go to sales LT and look at a mount point, okay? And since we only got about 20 minutes left, I'm gonna just go quickly over these, but not gonna run 'em. So help gives you a list of all the different things. So we can do file system stuff. We can parallelize notebooks, schedule them, so on. Credentials, pull from like Key Vault, work with a Lakehouse. We can query data. We can look at runtimes and session information. We can do user-defined functions, the variable library, and so on. So there's a bunch of them, right? And if you want detailed help for each one, you say help. So for instance, files, we can put a file, which is writing out some data, removing a file, unmounting, so on. We can also show off the mounts. So for instance, FS mounts, we can see there's a job mount, which is this my sales when I ran it versus, again, I didn't run it, but it would have been there if I did. This is the default resource and the default lake house mount, okay? And we can get like, for instance, this one says show me my sales data, and that basically gives me all the directories. So if we go back to um, the dashboard real quickly, and we go here, right, containers, right? Basically, I was using that notebook utils to look over, okay, into the sales LT. And basically it came up with all the directory names, right? Currency all the way down to fact. And if we look, we can see all the way down to fact. So it did that. We can also show the lake house path, right? And we can list stuff, we can make directories, we can copy, list files, and so on. So I'm going to let you go through the rest of this. I'm going to skip on to something more interesting. So this one was 5. So basically, what has changed? When I first see this, now I, by mistake, didn't stop it. See, this is the reason why you want to always go ahead and make sure. And we can see this is still running, which we don't want. So what I can do is go back to monitoring and kill it. Okay, finally stopped. Awesome. It was just taking a while. Okay, so what has changed? When I first looked at Python notebooks about a year and a half or two, they did not have this notebook utils configuration. They did not have the %SQL there before. So it's really important now that this is here that makes a complete ecosystem, okay? So far we talked about Spark versus Pandas in Python, right? And those are the two ways to do it, spark.read or pandas.read, right? Why use Polus, okay? Well, what's the difference between Python and Rust, right? It was built in Rust. Rust is something that compiles, okay, to the machine language, okay? It's like C, C++. Python is interpretive. It's like basic, okay? So it's significantly faster, okay? Some other things it does is it does query optimization. So Polus builds a query plan, optimizes it, and then figures out how to run it. It doesn't just start running it like some pandas does, okay? It automatically parallelizes it. It uses lower memory usage, and it uses different syntax, okay? So we'll talk about that. That's example 6. I'm gonna do some slides and then do all the examples at the end. So why use DuckDB? Well, core advantage is we have no cluster or server required. Runs in Python notebook extremely fast, but it's basically a database, right? It's a memory database. You can also store it to the local storage, bring it back up if you need. Okay, I wouldn't suggest that because, in Python, you want the ultimate result, you want a delta table, okay? Delta tables is what gets sucked into Power BI. But DuckDB internally, just like the other one, if we look back here, right, it says automatic parallelization. I don't think it's here, but it uses arrow, right? This uses column storage, right? It uses vector execution. That means it's faster, right? Parallel processing. And again, this is great up to a certain limit. I've seen up to 100 gigabytes. You can go ahead and see how your mileage varies. But those are the ideal use cases. It's great for exploring stuff. If you have a data scientist wants to do his own, little database, you can do that. You can replace Spark for small workloads and embedded analytics and pipelines. Okay, so let's look at 6 and 7. So we're going to go back to these notebooks. And again, these are all in my repo. You can have them. And okay, so I thought there was more in this. This is good. Almost near the end then. Work on time. So this time I'll let this go. And last time I said, I don't want to do it, but this time I will do it. Okay. This is going to take a little time. This takes, well, it depends. We'll see. This one only has two. Why don't I see if I can show you something different, right? Why don't we say we want to double, okay, the compute, okay? This is going to take a little longer because two is maybe not, but we'll see. Two is the default pool, right? Because that's where everything gets carved out with two virtual CPUs. This might take a minute to load. While this is loading, why don't we go over the table? So far we've done pandas, we've done Spark. Now we're gonna do Polus, okay? So this one, again, we've gone over, this gets the lakehouse path. We can print the lakehouse path. Let's look at what Polus is. We're gonna write a function called read CSV files. It's gonna take a path in and a dictionary, and it's gonna return the data frame, okay? So before, when we had multiple directories, we couldn't even scan a single directory. Well, nice thing about pull is it allows you to scan a single directory. So we can say scan CSV path, give it a schema, has header, collect all the data. If it's empty, then return an empty data frame. Otherwise, right, not empty. Otherwise, we return the pull list data frame, right, to execute it. Well, remember, we have, okay, multiple folders in my stock data. We have 5 years worth of data. So what's different here? We get the mount point, that's fine. But we can also see we get the directory listen, which we're going to pass to the other one. And see, it took a minute and 35 seconds. And here's our schema. So now this is different. We're using the POLIS definition of strings versus floats. And what we're going to do is we're going to process each folder. So for each folder, we're going to read this back. It's going to return a single data frame. And then we're going to append all the data frames, concatenate them using polas, and return it. Okay, so let's do it. So that started the actual thing. If we look down here, now we have twice the amount of compute. So we're using two CUs, capacity units, or 4 virtual cores and 32 gigs of RAM. One of the things we have to use is the path. So we're going to run this and grab the path, and we can print it out once it's done. So it's done. There, going to write a function to scan stuff, and then what we're going to do is, last time we ran this using pandas, it was around a minute, over a minute. I don't remember. I think it was 58 seconds. This one's going to run a little faster. Might have been, I think it was 2 minutes, and this was minute 58, and this is 48 seconds. So twice as fast. So we can see now it ran 3 of them, ran 4. We can see that the print is here, and then it did the concatenate. So 25 seconds, even better this time, see, because we're using twice the amount of cores. Awesome. Remember, again, it does parallelism. Last time I did it with 2 cores. We can get the head. We can see now, this looks like, you know, Power BI. We got the different data sets here, okay? Same thing, we're going to say, okay, remove the path if it's not there. And then we're going to filter where it's not equal to 0, so we're on read dividends, and then write delta. And what we need to do is take that publish and cast it to pandas, okay, for this to work. Okay, 3 seconds, that's not bad. We can also say, give me the 5 years and read that big file in. So syntax is easy. Okay, so read it in. Again, we're going to remove it. And we're going to write it out again. Now, if we hit refresh, we should get a bunch of polas coming up. So now we have the polas 1 stock file and a polas stock files, right? And again, this should fail if it's not on the SQL Analytic endpoint. Okay, it's there. So it's refreshed a little faster today. And again, some days it's slower. We're going to remove the target. So this one is the weather data. So we're going to redo the weather data. And how we're going to do it's going to read everything in, but we're going to do something different. This is recursive like the other one wasn't, right? Going to read everything in, collect it, and then what we're going to do is we're going to split it into two data frames. Join on the date and then write it out. So a little different processing, but same results. Okay, and then we're going to write it out. And so now if we hit refresh, we have polars, and if we click here, how about we do load data and run this. There we go, got the same data. Okay. So that's how you use polars. Again, it's a little different. The other one I had to get a list of every single file. This one I can say, hey, given a single path, read all the files, and it automatically does that. If I have multiple paths, then I have to concatenate them. Before, for every single path, every single file, I had to get the name and then actually concatenate it, okay? So I'm gonna stop this session. Okay, close this one, and let's go to DuckDB. And we're gonna connect. And I'm always paranoid about running out of CU, so oops, wrong button. I wanted one lake. It's not what I wanted. Monitor. There we go. So hit refresh. So everything's done except for this one, which is great. Again, we're going to get the path because these notebook libraries, they have to know they're initially written not for the cloud, so some of them not aware of paths, so that's why we need to get the path. Okay. So we're going to import DuckDB, import pandas. First thing is we can just do like, 2 plus 2 equals 4, right? Or say, hey, if you ever read the Hitchhiker's Guide to the Universe, right? It says the magic number is 42, right? So that's all I did in this example is the magic number is 42. Okay, that's pretty quick. Okay, this time, remember we had to go through and do a bunch of processing. We had to write a bunch of code, either to go find every single file, read every single file into a data frame, concatenate them for pandas, or for polars for each directory, read them into a data frame, and then concatenate them. This one, guess what? It's a lot easier syntax. DuckDB, pandas, give me the path. I want star star any directories, star.csv. Just read it. Pretty quick, huh? And it also runs in 65 seconds. So it's pretty fast. And again, I stopped the other compute, which was a custom compute, which took a minute or two to load. This one's back to a standard compute, which is what you get with a Pandas notebook or Python notebook, and it's 2 vCores, 16 gigs of RAM. And we can see how much it's using, 28% right now. So this is going to be limited by the number of vCores, right? The number of vCores, okay, in here is 2. So it only has 2 threads in which it can read up files at a time. It has to read up 2,500 files. So that's why it's going to take this amount of time. More cores will probably go faster. Okay, so it's done. And then we get a count, right? And this has the extra stock records. Remember I said there's dividends? So what we can do now is import pandas, right? Because we saved this as a fetch data frame. It automatically converts it to a pandas. We're going to replace all the file names. We're going to fix a date. It doesn't like dates. And then we're going to reindex and just write it out. Okay, so I'll show you the head and then we'll write it out. So there's some weird error here. It says that, a value cannot be copied, but it's correct syntax. We can see that it has the right information. It has an index. We can see the data types if we want. We're going to write it out now. So we're going to do DuckDB stock data. We're going to do the same thing. We don't have to convert it to pandas because it's already in a pandas format. And again, like I said, sometime this will happen right away. Sometime this will error out depending on how busy Fabric is. So right now it's erroring out because it hasn't loaded. Let's go ahead and come back to this. We can definitely look at the Sparks catalog. It's been updated, just not the SQL Analytic endpoint. So we can see this DuckDB stock data here. We could do the same processing in memory too. So before we read it, but into a data frame, this one we're going to say, hey, read all the files, create a table, and and then select from, read the files, and execute. So I'm going to save this in memory right now. So if we look, when this is done, we got 33% memory. If I go up higher, maybe I'll just leave it at 33 before it was like 28. Now it's 34%, so it is sucking up some memory. Again, the 2 cores, it has to read all 2,500 files. Yeah, the stock data is a good sample to use for this type of processing because it has a large number of files, right? And having a large number of files means that anything that's distributed will shine versus something that is, low CPUs won't. But it took 51 seconds. That's reasonable for me if I'm doing data processing and I don't have to pay much money. I can remove the target, right? And I can say, hey, now I have the select statement. I can select from it, right? And I can execute it, return date frame, and then just write it. Okay, so I'm going to write that. And again, this is going to fail because it takes a while to refresh. So now if we go here, we have stock data, top 10 stocks. We can also do the same thing from a scan, right? So we can say, can scan it in. So we can scan back that table. That's pretty quick, right? Even though this endpoint doesn't show it, it's there, right? Because we tried the endpoint, but this is the same thing, right? Table path. And guess what? It actually does a Microsoft stock and brings it back. Okay, let's do the last example. Read high and low. So this one, we're going to say drop the table exists in uh, the database. And then what we're going to do is create table as name, observation date. And then what we're going to do is we gave it a list. We're going to say first read in high temperatures, get rid of the table, and then create it with auto, low temperatures. So again, just a for loop over the two data sets. It read two data sets and yahoo. We can remove the target. Data engineering. We can say, hey, table name DuckDB, drop the table exists. We're going to create table as, and then we can just select from it and execute it. So it's going to create the table as that, and then it's going to create it internally. And then last but not least, we can execute selecting from that table name the results that we did. So what's the difference? We read the two before. We've done all data processing using pandas. This one in memory, we're doing a memory database. We physically created two tables, okay? Whatever format DuckDB does use, there's two physical ANSI tables here. Then what we're going to do is we're going to combine those tables and create a main table called DuckDB weather. Then we're going to select from it and then just write it back out, okay? And look at this, I'm finishing right on time, which is awesome. And that took 1 second. Guess what? It doesn't like that. But if we run this, guess what works? So again, this is reading directly from the SQL endpoint, Spark endpoint. This is reading from the SQL endpoint. SQL endpoint's not up to date yet. So in summary, I've showed you many different ways to read data. We can read data with Spark. Problem is with Spark, it might cost you 8 CUs. You got 16, you can run 2 jobs. With Python notebooks, if you can do the same thing with 2 virtual cores, it's 1 CU, so we can do a lot more jobs. Best practices. When doing this, have some type of medallion architecture. I showed you bronze is raw, silver is like you clean, gold is business ready. Um, Summary, right? People are looking to save money, right? How can you do that? If you can run the same data processing using Python, then you can do more with less, okay? There's different ways to do it, right? We talked about Pandas as a default. It's an older library, it's a little slower, but works. It's a little harder to use because it doesn't do scans on like multiple directories, okay? Polls will do a single directory scan for you. So if you have all your files in one directory, it's fine. If not, you can use a for loop and concatenate them. DuckDB is even better. You just give it some wildcards and it reads everything up, okay? Nice thing about DuckDB too is if you don't like doing data processing in Spark, you can do it in ANSI SQL and then write it out, okay? I suggest starting off with Python notebooks and for small and medium, and if your data grows and it doesn't work, convert to PySpark. It's not hard to use. Definitely use the medallion architecture. That's one that gold, bronze, silver, gold, or and we can also do raw, right? That's the data without changing. Refine, you cleaned it up, duplicates, add more data, curated. Guess what? Now you have your star schema, right? And last but not least, yeah, if you start with the small ones and it's reusable notebooks, and you have to go from Python to Spark, guess what? You only have to change a few notebooks and you're done, right? Here's a bunch of links. MS Learn, Fabric, Polas, Mastering DuckDB, and that's it. Thank you for your time. I'm going to stop sharing and answer any questions. I didn't see any chats. If I did, I apologize. There's Spark Notebooks. Okay, let's read. Spark Notebooks using Databricks and Fabric. Do we learn Python Notebooks? What's the code difference? Okay, so Databricks does not have something called Python Notebooks. It's only Spark Notebooks. What Microsoft came up is they have this concept of shared capacity. It's like the mainframe. And going back to the old days, right? And if you run out of capacity, then you have to pay for it, right? And that's called bursting. So they'll give you some money, but then you have to pay it back, and that's called throttling. So here's like you're 16, you burst up to 32. Guess what? You have to pay it back. So eventually, maybe they'll knock you down to 8 for a bunch of time so that you can pay it back. Okay, that's bursting. So again, uh, if you have a small company, you use an F16, you can only run 2 Spark jobs. If you write Python notebooks, you can run 16. So that's why you want to do this, okay? What's the code difference? The code difference is one's PySpark, right? And it has its own language in PySQL. And the other one is 3 notebooks that are libraries I showed you. Pandas is by default, okay? And the second one is Polis. Polis is a rewritten of Pandas, okay, to make it faster. It's a column store index, uh, parallelized, it just goes fast, right? And it's written in Rust versus Python, so it's quick. And last but not least, DuckDB. It's an in-memory database that allows you to use ANSI SQL. So I hope that uh, works for questions. Any other questions?
Yeah, I had one question, John. Yeah. So you mentioned, yeah, actually, you whatever you mentioned is exactly correct that we have to use Python for small data purpose, and when it goes to large data or big data now, which way we are evaluating, so streaming purpose, so we have to go with PySpark. Really, I think many of the team don't know that when we have to use Python and when we have to use PySpark and how it can be used. So that this session has helped. But the question here is, so when we use the Python notebooks, so what is the computing engine or which one you will suggest more other than you will use Spark or how we can, which other we can use?
So again, Databricks only has one type. So there's 2 players out there, right? Databricks is first to the play zone or the market, right? Because they built Spark, right? And with that, you can only use PySpark. So you're going to get charged regardless. Now, there's 2 ways in Databricks to instantiate stuff. You can have a defined compute, or you can use serverless. Serverless is kind of like the notebooks I showed you, the starter classes. They come up really quick, okay? So let's put that aside. With Databricks, you can only use Python, so there's no decision. And PySpark, there's no decision. You always have to use Spark with Databricks. Now, talking with Fabric, you have 2 choices, right? You have big data, you have Spark, small data, you have Python. That's it. And you can pick which engine you like. If I say if you're happy with Pandas, go with Pandas. If you want to go a little faster, go with polars. Polars is interesting. The problem with polars is that you're going to have to use all those, when you pass a schema, you're going to have to use the polar dot, whatever, um, constant there so that you get the schema correctly. But other than that, it works perfect, right? And there's probably a lot of things. DuckDB is awesome, though. I like DuckDB because with DuckDB, you don't have to worry about going ahead and doing file path or recursion and then like concatenating stuff. It just does it for you. So pick what you're comfortable with. I say maybe start with DuckDB. I like DuckDB. It's easy. Does that answer your question, I hope?
Yeah, yes, John, really that helps. Yeah.
Yeah, and here's the thing. I'll put you my address here. I'm a busy guy, but if you ever come across something and you just want to chat and say, "Hey, I got an idea," just send me a note there. That's my work one. I look a little less often at this one, but that's that one too. I don't know if any of you are going to the Databricks Summit, but I will be at the Databricks Summit in a couple weeks, talking about DBT. It's not a cool tool, and or Lakebase, which is Postgres.
Yeah, are you attending the San Francisco one?
Yes, I am.
Oh, okay, good.
So are you there, Lanka?
Yeah, no. Actually, I think I have planned it, but due to some deliverables, I did not. I'm not coming.
Okay, if anyone from your team or whatever, stop by the Insight booth. I'll be there. Awesome.
Great, John.
If there's any other questions, I'll answer
Thank you
them.
so
If
much.
not, it's sad day here. I'm going to go enjoy my long weekend.
Yeah. I don't think there is no further questions. I already posted a LinkedIn chat. So if there is any further questions, they are going to reach out to you. And it's a wonderful session, John. Thank you so much. Thanks for sharing your views on this topic, and looking forward for further sessions as well with you.
Awesome.
You already registered for multiple sessions with us. So thank you so much. Again, looking forward for a few more interesting sessions.
Awesome.
Thanks,
I
John. Thanks,
appreciate
everyone.
that,
Thanks for
and I
joining.
love to talk. So hopefully share my
Thank you.
knowledge. Thank you again, and have a great weekend.
Thank you.
Take care.
Great.
Bye.
Yeah, thank you. Have a good day.
Thank you.
Thank you, sir.
Thank you. Bye.